Hello, hi everyone. So welcome back to my channel and apologies for not uploading the daily challenge video for the last 3 days as I was not keeping well and won't be able to do that. So let's just start with today's question. So we are given a string and we have to return the maximum number of unique substrings that the given string can be split into. So if you see, we have to split this a string into substrings, and it is also given that concatenation of these substrings form the original string. Okay, so we have to just split at add the split here, add the split here, and we have to do the count, and all the substrings should be unique. So we are given this thing, and we have to given the maximum number of unique substrings that we can form. So if we just directly see the example, this is AB 3 times C. So how we can split? First we can split this A. Since we need maximum number, so we need the substrings of the least size. So first should be first size. Okay, next B, yes we can have because it is not anywhere previously seen. Again A, we cannot use single character, so we will try to move it together with next AB. Okay, so yes we can form AB because it is not seen earlier. So three substrings we have, and then for three C's how much we can have? If we split into one, so C is already not seen, so we can include it. But if we split this C again, it will not be included because it is already seen before. So we'll try to include other character that is coming up next. So 2 times C, yes, so we can include it. So far we have made 5 as our answer, and if we can try to build other examples, other substrings from this example, we will get 5 as our maximum answer only. So that is the answer. So let's just move to the intuition building part. Okay, so we have this example. If you see, the answer is 5. How? We can try to split it like this: A, then B, then AB, then 1C and 2C. Or we can do 2 first this AB, then A, then B. Okay, 3 parts are done. Now this C, how many it can give? It can give either like this or it like this. So possible solution can be first is A, then B, then AB, then C, then 2C. Or it is first this part, then AB, A and B, because it should be unique. So let's just write the constraint here, unique. Okay, and this C, how it can give? Maximum it can give 2, because if we use 1C, then 2C we have to use together. Or if we can make it like this. Okay, 2C then 1C, both are same because the number is only 2 and we have to make use of that only. So if you try to see, max, this is 4, and if you try to split it like this, first we use AB. Okay, one of the answer can be first is AB, then we have to make it unique. We can use A, yes, we can use B directly, yes. 3 C's, first we have done this 2C 1C, and we can do this like 1C 2C, and the other can be 3 C's together. It is also unique. So if you try to see, this is your 4, this is 5, this is 5, so you are still smaller than 5, so you cannot make it your answer. Okay, similarly you can make multiple options, but if you try to see, the maximum answer that you can get is 5 only, and it can be either of them. So, and you just have to return your answer. So how we can come to this part to make our best answer? Let's just try to make possible solutions. How we can make those possibilities? So since we came to know that we have to take every possibility and check our answer if it is maximum, so it is using somewhere possibilities, and we generally know if there is any possibility kind of thing, we have to use recursion with backtracking. Okay, so we will use it here similarly. and we will make our answer. But we know that we have to use recursion and backtracking together because we are need to compute all the possibilities and make our answer. So how we can do, this is your first part. Okay, if you try to use this a and make your substring, it can be a, it can be ab, okay, it can be aba. Using this you will make it this. Substring is a part of string, you cannot make aa. Okay, it should be this, starting from this, and every character you have to join. Okay, substring is a subarray in arrays. So aba, then abab, okay, then ababc. Similarly you can make. So what you are doing, if you see, you are basically using this part, okay, doing for this part. And what you are doing, if you use a, then how many substrings you have to make? What is the string that you have left? You have this string left, and if you can make, let's just say you can make 4, and what is this here? This is 1, so 4 plus 1 is 5. You can get your answer, right? And if next time what you can have, if you try to make this as your substring, right, ab, okay, ab your substring, then how many part is left for this string? This part. And you need maximum answer. Let's just say it will give you 4 or 3, right? So if it is giving you 4 or 3, your this count is 1, so your answer will be, in one case it will be 1 plus 4 is 5, and in other case it will be 1 plus 3, that is 4. Your answer is 5. So this is how you will compute. You take your part, okay, you will do for your part, your work, okay, and check for left part. Okay, left is here, that is left from the other part of the string, not the left right thing. Okay, you will check for the left part of the string, and this will give your answer, this will give your answer 1, and this will, let's just say, any variable, and you will make your answer then. So this is how you will compute. So we will do one small try run for this example only, how we will get our answer and how we'll approach it. So if you see directly, you will come here, right, a. So what you will do, you will include this in your substring and call for this part. Okay, so let's just use a storage, because you have to maintain this uniqueness. Okay, giving you 4. How you know that it is giving all the unique substrings? You need to maintain some storage, so that you include this a and let your this part of the string knows that you have a this a as a substring, so that it will not make a unique same substring as your answer. Okay, so you will make a storage and let use this part of the string, this storage will use, okay, and make your best answer. So you have computed a, you have added, and this part will now work. Now this part, so this part is b, a, b, c, c, c. Now you will use this, okay, b. So what you will do, b will check if it is already present or not. Not present, so it will add here b, and it will ask for this part of the string to make your best answer, because till now you have one. How many strings you have? 2. And this will check how many substrings it can have to make your best answer. So again, what it will do, it will have this a, b, c, c, c. So again it will split from a. It will check again, a is present, yes, a is present, so it cannot use a as your substring. So now what it will use, it will include the second character, ab. Okay, now you will try to split at this point, ab, yes, if you check it, it is present, no, so you will add it here. Okay, ab will be added here, and this will be splitted, and this part will be called with this storage to check if you can make best answer, including these substrings are already done. So how many substring it can make? Let's just say now you have C, C, C. How we can split it? It can be split into here. Okay. Now you see C is present? No. So you will add C here. Okay. C is added, and this part will be called with this storage. It is unique substring storage. Okay. So this part will be called with this storage to store your answer, to store your best answer, to make your best answer basically. Now again C, C, and you try to split it from first character. C is already present, right? So you cannot do that part. So what we will do? We will include this character in your substring, and you try to split it at this point. Okay, C, C will be it is present? No. So you will add CC here, right? And what is left? Only this empty string, and you will try to call it. So you will call with this. Since now it is empty, what it will do? It knows that you have made your answer. You have reached till the end. Okay, you have reached till the end. You have made your answer. So how many unique substring you have? Okay, this storage you have with the unique substrings, and you are already computing all the basically all the characters which can make your unique substring. So this will, what is your answer? So your answer is, if you see, this is storing your answer, right? So this storage is storing. So now answer is storage dot size. Okay, and how the compute we can make maximum? So it will be similar to this, answer equals to max of earlier what you have computed and your current storage dot size. Okay, your storage dot size will make your best answer. Now if you see, you will come, since this is a recursion, so you will come back to this CC. Okay, you have included this CC. Now if you try to make your answer, when you try to split in this string A, B, C here, okay, or anywhere, okay, so you have to remove this CC, because when this will call, okay, if it has used this AB, now if it try to make this string A, B, C, and then it will call for this CC, and it is not present in your storage, it will call automatically with this string CC. Okay, now you see C is already present, so it will not be able to call, and again CC is already present, so it will not be able to call for this. But if you want to call it for this CC, you have to remove this CC when you come out. So one thing that we also do in recursion, when we come out to this step, or we can come out to this step, or we can come out to this step, we have to undo also the work we are doing. Okay, undo that we use. So it is, since we are adding in a storage the substring CC we have added, so when you come out, when you compute this, you have made your answer. So when you go back to this step, okay, when you go back to this step, what you have to do? You have to remove this CC. So once your work is done, when you go out to this step, remove, you will also call remove this CC from your storage. Okay, so once you come here, CC will be removed. Now when you try to compute for this, see this part ABC and CC, you will not have the CC, and you can make your answer. So this is how generally backtracking kind of thing we do. And first we write our pseudo code to make you understand more how we can do. So let's just write it, pseudo code. Okay, so pseudo code will be what we have. We will have to make one your answer. Okay, and this is a unique storage, right? Unique storage, unique substring storage. So which data structure we use generally for uniqueness? Set. Okay, so in C++ we have unordered set, which is also called hash set, and in Java it is directly. So this will store the string type, not character, because we are storing strings. Now what you have to do, you already have one function in your example, so we use one other method. Let's just say solve, and how many variables it will have? It will have this original string that you have. Okay, this original string. So string, just say s is here, and now you have to have this storage, so it will be unordered set st. Okay, I'll just add the names so that it can be placed here. S, it is your string s, your original string, and your storage and your answer. And one more thing, what is that? The main thing that you know, this, how you can know that you have done part for this. And if you have done part for this, what you have to do, you have to include this, then you have to include ABA, then ABAB. Okay, because here we have what we have computed, that it will do A, then it can have AB as your starting, then it can have AB as your starting, and the left part will be CC. So for starting, you have this, you have to AB, then you have to ABAB. So how you can make it? You need to have some index, int idx, right, from which you have to start. So you have this. How you can do now? Now you have to use one for loop. What it will do? It will use this indexing from this I, from the index you have till the index you are using in for loop. Okay, so let's just say for int I, from which idx you have to start, the index you are having and the next of it. Because how you can make your substring, you need to have your, let's just say your idx is here, so from this part you have to start. Okay, you can start from here, you can start from here, anywhere. So I say I is here, so what is your first substring? You need to have this, so it will be I minus idx will be your length, because it is 1, it is 0, 1 minus 0 is 1, and your starting is idx. So you can have your substring from idx, this is will be your length. Okay, so let for I, this I less than equal to string dot length I plus plus. Okay, and first your substring will be s dot substr, this is our method. Starting index will be idx. Okay, so idx is your starting index, and your length will be, if you see, your I is here, sorry, your length will be I minus idx directly. Okay, because I is at 1, id is 0, 1 minus 0 is 1 length, and from this index, one length is this only. So your, when your id I is here, so your length will be 2, so you will include this. So if I is here, how much is your length? Till this C, right? Now you have to include this also, your one of your substring directly, so you make your I place here. So this is your last. So if you see 0, 1, 2, 3, 4, 5, 6, string length is 7. So this is your 7th position. That's why I have moved I till string dot length. So your length will be I minus idx, right? Now you have your substring, you have your storage. What you have to do? You have to check if storage dot find this substring. Okay, or there is another method that this set provides, set dot count. So it will check if there is any count of this. If it is 0, that means it is not present, so you will add it. Dot insert, you have added this substring. What you have to do now? You will call for the left part, right? This is your left part from B till C. So you will call, which will make your answer better automatically. because it will compute for this, then this, and then this, then it will finally make your answer, which you need to handle at last. Okay, so now you have inserted, you have to call again this solve. String will be same, storage will be same, answer will be same, right? Currently, because you will make your answer when you reach till end. Now your idx will be, because now your idx was at 0, now your idx will be this. So what is this? Your I, if you see, so you will pass this and I with here. Now you know you have done your part. When you come back from this function, you have to remove that to make computation for other possibilities. So you will erase it. Set dot erase this substring. Okay, I think this is the main approach that we need to do, and we have made our answer. Do your part, check for other or left possibilities. Okay, and best is undo your work, undo your part. Now this will be called, when you know it reaches this, you have your storage with all the unique substrings. So what you have to check, you will check here if you have reached your last. So if idx is, what is the last? String dot length, right? If it reach your last, answer will be maximum of your answer, and currently storage is or holding your answer, storage dot size. Okay, now you have made, and you don't have to go further from this index, so you will just simply return, right? So this is a small pseudocode that we have now. But if we will do the try run with the coding part directly, and we will make our answer. So let's just move to the coding part, and we will discuss the time complexity there, right? So we have this function. What we all require, we require an answer that will be 0, and we require one unordered set of string type set that will hold a, let's just say, unique substrings. Okay, now what we have to do, we have to make a function solve. What it will require, string, your storage, your answer, and your index. So initially index is at 0, so we'll make it call with 0. We have to return our answer, right? So it will be a void type because we are not returning anything. Now solve, so it will be having string s. Okay, and it will be having a set, as set basically, and it will be having a this answer and one index, right? Okay, so let's just, okay, so let's just start with it now. So we have our index. Now what we have to do, we have to call one for loop, and it will be starting from idx plus 1 till string dot length. So it will be dot length and I plus plus. Now what we'll do, we have our, we have to make a substring. So string sub will be, substring will be s dot sub str. Starting index, we know that this idx, okay, this idx, and length will be, we know that from I till idx, so I minus idx. Now what we have to do, we have to check if this set is containing or not. So set dot count this substring, right? If count is equal to 0, that means it is not present, so we will add it. Insert this substring. We have done our part. done our part. Now we have to compute for other possibilities. So we will call this solve function again. String will be same, set will be same, and answer will be same. And this idx will be, currently we have our idx at here. Now we have to compute for b, a, b, c, c. So I is here only b. So we have to pass this I, right? And this will compute for other possibilities, right? And now we have done our part, compute the possibilities, we have to undo it. So set dot remove substring. It is erase function, sorry. So it will remove the, undo the part we have done. Okay, because we have to remove this substring so that we can make best answer while going forward. Now we have done most of the part. What is now left? The main thing, when we reach at this position after C, we have to make our answer that we may require for this. When you reach here, what is your answer will be? Your IDX will be S dot length, then only you know that you have reached till end. Now you have to make your answer. Answer will be maximum of your current answer and this, the size, right? And since you have done your work at this point, you have to return, because you cannot compute for other part because there is nothing left. You will return basically, and we will add a ampersand sign here and at all the basically parameters, because one main thing whenever we do a backtracking recursion type of thing, and if we have one storage or anything we are using and calling this function again, so it will be, if you are passing this directly without ampersand, so it will try to copy it again for the next call, and your memory utilization will be more. And if you use this ampersand sign, so it will directly pass the address of that storage or any variable, and it will be directly used from that address instead of copying to another address. So that is main thing that we require, and it is also like quite helpful while you do the work in big companies or any interview you have to do. So you will try to use this. Now we'll just try to run it. Okay, so it is causing in max. So we, what we can do, we can store the size, and size will be size, and then we can check. Okay, what is it, the issue? IDX answer. So what is this error? Okay, since we are changing this IDX every time, so it should not be similar, but we have to get our answer so that we can use it directly here, and storage also, so we can use it. I think now it will to work. Right, so it is working fine. So because if you are using the same thing every time, and so at that point of time you can use it, but if you are making every time dynamic changes to it, you cannot use ampersand sign, because we are every time changing this I, so we cannot directly use ampersand. But since we are not using storage, not changing storage, so we can use ampersand and similar for string under answer, because we require it here. So let's just try to submit it. Yes, so we have submitted this successfully. Okay, and now we will do the time complexity and space complexity. Now we have to talk about space complexity and time complexity. Space complexity is directly big of n. If you see, we are just using one storage set, okay, as set, and it is storing all the substrings at max. Since if all of the characters are unique, how many substring it can store? N. So we can store n. Now comes the part of time complexity. That is the main thing. If you see that in the recursion questions, so if you see this recursion questions, in every recursion with backtracking question, the time complexity generally comes out to be exponential. So in this case also it will be exponential, and since we are doing part for one part of one string, that is one unique, and we are calling again for the left part, so it will try to compute all the possibilities, and the maximum it can be exponential 2 raised to power n. Okay, so it is like this, 2 raised to power n, right? So the maximum time complexity it can have is 2 raised to power n, and space complexity is big of n. So thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications. And if you have any questions, please do ask in the comment section. I will try to answer all of them. And if you have any alternate approach, please do ask in the please do reply in the comment section. I will try to review them so that we can share it with everyone. And thanks everyone.